The end behavior of a polynomial function is determined by the leading term of that polynomial. But what if that polynomial is not in the standard form, but rather in factored form, as in our example? Do we have to multiply this polynomial out to get that leading term? And the answer is no. What we need is just the leading coefficient and the degree of that polynomial. To find the leading coefficient, we need to make sure that each factor of that polynomial has the leading coefficient 1. If not, we factor out that leading coefficient from each factor and we multiply all of them, because that's what we can do at the end, and the product of all these leading coefficients will give us the leading coefficient of the whole polynomial. So if you look at our example, you can see that first factor that contains x has the leading coefficient 1, the second has also leading coefficient 1, and the third, x squared plus 2, also has leading coefficient 1. So our polynomial is already in the right form. All leading coefficients of factors with x are 1, and therefore the number that stands in front of the whole product of the polynomials is the leading coefficient. So the leading coefficient of the polynomial is 3. Now, as for the degree of the polynomial, we have to remember that the degree of the product of two or more polynomials is the sum of the degrees of all the factors. So it is enough to determine the degree of each factor and add them all to get the degree of the whole polynomial. So let's look at our function and let's list the factors. The factors are 3, then we have x minus 1, then the next factor is x plus 4 squared, and the last factor is x squared plus 2 to the power 3. The 3 has degree 0. The x minus 1 factor has degree 1. X plus 4 squared has the degree 2, and x squared plus 2 has the degree 6, because this is the third power of x squared plus 2. Each factor has the exponent 2 or degree 2. So to get the exponent of that power, we'll multiply the degree of the x squared plus 2 by 3. And therefore degree of the whole polynomial will be 0 plus 1 plus 2 plus 6, which is 9. So we know the degree of the polynomial, it's 9. And therefore we can form a power function. That function f of x resembles when x has the large absolute value. This function is y equals leading coefficient times x to the degree of the polynomial. This function, y equals 3x to the 9, behaves like the cube function because the coefficient is positive and the exponent is odd. So the graph of that function is this is the graph of the function y equals 3x to the 9. Now we know that when x is large, as far as absolute value is concerned, then the graph of the polynomial f of x behaves like this graph. So large values are on the left end. It means that I will start the graph of a polynomial f of x by going up from the bottom and end this graph when going up when x is large and positive value. So these are the parts of behavior of the graph of function f of x when x has large absolute value. So this is the end behavior of the function f of x.